This is chapter 3, which is to show you how to do a nuclear equation regarding nuclear fission. And so what you can see here is that we have a reaction that's taking place here. So what's happening is a neutron is bombarding an uranium isotope. It's creating two new isotopes along with 4 neutrons. So writing this out in terms of writing an actual equation, nuclear equation for this, to kind of symbolize this, what you would do is you would say 235 uranium, and these numbers right here, so what these numbers actually represent is this is your mass number, and that means it is made up of your protons plus your neutrons. Protons have a positive 1 charge, neutrons have no charge to them. Your bottom number represents your atomic number, which is the number of protons. So knowing this number and knowing this number, you can determine what the total number of neutrons would actually be in a reaction. So back to our example. So if we're writing this out in terms of the actual reaction that's going to take place with this, so you will do this. You're going to start off by saying 235 uranium, which is this isotope which weighs 235 grams. Then this is going to be added to 1 neutron. And when this reacts, it produces antimony 125. Which is element number 51. So it has atomic number of 51. So that also includes niobium 106. And we're going to go ahead and leave this blank for right now. And we're going to show how we actually can determine what this would be. And then also, as we said, 4 plus 4 neutrons. So if we're looking at this reaction, we notice that what you have to do is you have to add up all of the atomic numbers. So this entire side has an atomic number of 92. On the other side, it's the same thing. This plus this plus this has to equal 92. So if we have 51 here, 92 minus 51 equals 41. So that tells us that this must be 41 for its actual value. Now adding up the total top, you notice that this equals 236. So if I add this number plus 4 times this number, which really means that it's going to be 4, adding them together, you should get 236. This is a chapter 3 tutorial video on nuclear fission. So what you can see right here is we actually have a reaction taking place. And what is happening in this situation is a neutron is bombarding an isotope of uranium at a mass of 235 grams, which then creates nuclear fission, which nuclear fission just means that it's going to be splitting of isotopes. This creates a barium atom isotope and a krypton isotope, and then 3 neutrons. So when writing this out in terms of the actual reaction that would take place, you would say that we have uranium 235 plus 1 neutron yielding barium 141 plus krypton 92 plus three neutrons. And what actually happens with this is it creates what's referred to as a chain reaction, because then this neutron right here is going to kick off and it's going to hit another 235 uranium isotope, and it's going to do the exact same thing with this. So this is going to go on and on and on. So based on this information we have, let's kind of backtrack for a second and talk about what the simple notation actually looks like for a nuclear reaction. So you have uranium-235, which has an atomic number of 92. So if we're looking at this, the top number represents your mass number, and that is going to be made up of your proton. However, this number up top can change, and that's all based on whatever the mass of the isotope actually is. Now, finding the number of neutrons that you actually have, you're just going to subtract the 235 minus 92 in order to figure out what that number actually would be. So, back to the example that we actually have here. We have this as our total reaction for this. So as we said before, looking this up, this is 92. In terms of the barium, if you're looking at barium on the periodic table, it's going to be 56. Krypton is 36. So when they give you a problem which is related to this, they're going to have you fill in the blanks for these isotope notations with this example. Here is what you need to know though. The bottom number, which you have, which is this 92 plus 0, must always equal the same from the left side of the reaction to the right side of the reaction. So if I add 56 plus 36, that also equals 92. So you can figure out what these are. Either it's going to give you one of a couple of different things. They can give you this, and you have to determine what that is, and that's just based on the element symbol for on the periodic table, or they can just give you barium, and then you have to solve for the 56. On the top, you have 235 plus 1, so it's 236 on top. And if you add 141 plus 92 plus 3 times 1, you also will get 236, to show you how it all equals out in the end.